One of the main factors that we deal with in tech support all the time is airflow. This is why we emphasize airflow in most of our classes. Usually when we're talking to a technician about an issue, they always tell us, I've got good airflow. But I'd like for you to consider turbulence and recirculation or reverse flow. Two things that technicians hardly ever take into consideration when they're thinking about airflow. One of the first things you want to take a look at when you're considering airflow is the filter in the furnace or the air handler. Most homeowners tell us they change their filters regularly, but we know that's not true. So making sure that the filter has been changed and is clean is the first step in assuring that we have proper airflow. If the filter has not been changed, or maybe even there's not a filter in the system, the evaporator can become plugged with dirt and debris. So make sure that the filter is clean and the coil is clean and spotless. The next thing you want to look at is the temperature rise through the furnace. This will tell us if we're moving the correct amount of air through the furnace. Every furnace on their data tag has a list of the temperature rise range that is to be expected for that particular furnace. In this case, this is a multi-stage furnace, and so you have 3 different temperature rise ranges. You should check the furnace in all ranges that are listed on the data tag. Once this has been adjusted, then you know that you're moving the correct air through the furnace. Taking the temperature rise through the furnace, you want to take the temperature of the supply air far enough down the ductwork so you don't get any radiant heat off of the heat exchanger itself. And then you want to take the return temperature and subtract the two to get your temperature rise. Once we have verified that we have the proper airflow through the furnace, then we want to make sure that we have the ductwork laid out so that we have the maximum amount of airflow throughout the entire system. There are many types of ductwork, hard duct and flex duct, and all of these need to be checked along with each register and the type of transition that you have to make sure that we don't have excessive ductwork in the system. Every fitting and transition that you put in the duct system will add equivalent length to the duct. So you may have a duct run that is 10 feet long, but by the time you add the transition and the registers on that duct run, you may have a duct run that is over 150 feet. These fitting equivalent lengths are listed in the manual for ductwork. You'll notice that the 4G fitting has an equivalent length of 80 feet. A comparable duct fitting in 4J has an equivalent length of 30 feet. So you want to make sure when choosing your registers and your fittings that you're not adding excessive length to the ductwork. The other thing that you want to take into consideration is the configuration of your ductwork to the furnace or the air handler. Follow the manufacturer's specifications for the type of returns and supplies that can be attached to the furnace or the air handler. Most coil cabinets are designed to fit directly on the furnace or the air handler, but there may be cases where you need to put a spacer between the furnace and the coil to provide good airflow and to eliminate turbulence. Check with your manufacturer for diagrams such as this for ideas of how to space or place the coil on the furnace or fan coil for proper airflow. In this example, we're showing a very common way that a horizontal furnace is ducted. You'll notice that the coil is directly on the furnace and the airflow going through the coil seems to be good, but once it gets into the plenum, there's quite a bit of turbulence that occurs there. Also note that with the takeoffs, the equivalent length of each takeoff is 35 feet, which gives you a total equivalent length of 140 feet before we even get out of the furnace. This could be done differently to provide better airflow and less equivalent feet. Two changes have been done in this example. A 12 to 18 inch transition has been put between the furnace and the coil, which provides smoother airflow and totally bathes the coil with air. We also have put 45-degree transitions off of the plenum, which gives an equivalent length of each fitting of 10 feet. So instead of over 100 feet, we now have 40-foot equivalent length out of the box. This is another common fitting that you see on most supplies off of furnaces. And you'll notice that in the first example, with a 0.50 HW ratio, the equivalent length of this type of fitting is 120 feet. In the second example, with a 0.50, with a 45-degree transition and tapered head, it drops that equivalent length to 35 feet. By further putting in vanes or a transition, we can drop that equivalent length to 20 feet. So which example do you think is going to provide more efficient work of the furnace and better and less turbulent airflow through the ductwork? Another example, but with ductwork going off both sides of the fitting, you notice at a 0.50 HW, the equivalent length of the top fitting is 120 equivalent feet. By simply putting turning vanes in that same fitting, you can drop the equivalent length to 20 feet. Another transition that is seen quite often is on the left, which if you do it this way, it's 30 feet equivalent length. If you put a transition on it, you can drop it down as low as 5 equivalent feet. So as we said at the beginning, airflow is one of the biggest issues that we face. And I know you guys in the field deal with space all the time. And on new construction and actually on retrofits, you don't have a lot of area to put transitions in that are going to provide proper airflow. But if you're having problems with a furnace tripping on limit switch or any heating problems, you're going to have to follow some of the examples that we presented in this video. So before you run your ductwork or before you condemn the furnace, take a look at what's connected to the furnace and how the airflow is in and out of the furnace. It will make a big difference on the proper operation of that furnace.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.